Hey everyone, this is Kenil. I am a dev support engineer at Polygon Labs, and today this workshop is regarding how you can bridge your any ERC20 assets across chains connected to AggLayer using Unified Bridge. Um, bridge any ERC20 assets using Unified Bridge. And this is the whole architecture for that. Like before diving deep into this architecture, I would just like to explain how exactly it will work on a high level overview. So as soon as you, so it's the whole architecture where the unified bridge contract plays an important role, and unified bridge contract is deployed on L1 as well as all the L2s that are connected to AggLayer. And you can use those unified bridge contracts on all these L2s while bridging assets. So it's a copy of instance of all these L2s, of these contracts on L2s. So yeah, that's the whole architecture, and yeah, let's dive deep into it. Yeah, this is the whole flow on how will your transaction go through from each and every Merkle leaf nodes as well as Merkle tree roots. So let's say as soon as you bridge your assets, it will basically, add a leaf to the local exit root tree. It's just a basic Merkle tree with 2 raised to 32 Merkle leaf nodes. And as soon as you bridge your asset, it will so bridge asset will contain all the information regarding your destination chain, your destination address, your token amount, token address, etc. So this information will actually be added into this Merkle leaf node, and it will basically hash the Merkle leaf nodes, two of the Merkle leaf nodes, and it will create a hash for that. And essentially, it will create a local exit root tree on the L2. So basically, it's just a hashing of leaf nodes on every local exit root tree of rollups. And at the end, it will update the global exit root tree node, which is on the L1. And this is how exactly you will verify that my asset is being bridged from L2s to other L2s or just from L1 to L2. So yeah, so as soon as you bridge your asset, it will add as a left node, and it will add it to the Merkle tree to the local of the local exit root tree, and it will update the local exit root as soon as a new bridge asset leaf node has been added. And next, this local exit root tree, not the tree, but this local exit root, it lies on the L2 or any layer 2 chains connected to AggLayer. So it just lies on the L2. But as of now, your L1 or your destination L2 doesn't know like what is exactly happening. So basically, you actually need to update the second root, that is rollup exit root. What is rollup exit root exactly? So basically, you have 5 layer 2s, for example, and there is a single rollup exit root for all these 5 layer L2s. And as soon as, so it's something like as soon as you add leaf nodes to multiple local exit tree roots, it will update multiple local exit tree roots, right? But there is only one root which is called rollup exit root, and it will update that rollup exit root to get synced with all the data and to basically be updated of this current state of the blockchain. So it will just update the rollup exit root. It is on the Polygon rollup manager.sol contract, which lies on L1, that is mainnet. And this again is just a rollup exit root. So it contains, you can say essentially that it contains the state proof or Merkle proof of all the L2s, but not, we are still yet to have the mainnet exit root here, which essentially contains all the information of all the rollups as well as L1. So, and here you actually get the data of my bridge asset, which is added on the layer 2. So yeah, here we come. So as soon as we add this rollup exit root, as soon as it updates the rollup exit root, and eventually it also updates the global exit root. Now what is global exit root? Global exit root is a root node of, for example, if you take a small example, global exit root is a root node of 2 lifts, that is rollup exit root and mainnet exit root. And mainnet exit root is basically root of all the bridge message or bridge asset leaf nodes of the mainnet or of the L1. And this rollup exit root is basically root of all the leaf nodes of all the local exit roots of all the rollups. It's pretty confusing, but all you need to know is like it's just putting a Merkle proof on the L1 so that any L2 can read it and actually claim the asset on the destination chain. Like it's just a proof, a Merkle proof that says that, hey, this asset was bridged on the source chain. Now it's ready to claim. Please claim on the destination chain. So it essentially just says that. So yeah, this is the whole architecture. I would not deep dive into it, but you just need to keep in mind that global exit route is the route that you need to get to claim the asset on the destination chain, because we are waiting for the L1 finality here. So yeah. Here are the code examples. I just go over through one code. I'm not sure if it will work because my PC is giving some issues. My laptop is giving some issues. So I just try it out by cloning my repository here. Yeah, this is a small example where you bridge. We will create first a token, ERC20 token named egg, and we will deploy that token contract on Sepolia, and then we will mint that token to our address. We'll approve that token to this unified bridge contract address, and then we will try to bridge it from Sepolia to Polygon zkVM Cardona. So yeah, here we go. I hope that is visible. Yeah, okay. I will be needing a couple of things. I think this might take time, and I think we are short on time. Let's try if we can. Let's probably let's just try to understand the code as of now, because to gather some API keys for Sepolia as well as for Polygon zkVM, it might take some time. And yeah, so let's go ahead and just first understand the code. I don't think we have much time. Yeah, oh, I think we have 30 minutes. I think we can do that. Let's go. Let's go ahead and grab some API keys to connect to our Sepolia as well as Polygon zkVM Cardona network. Let's go ahead and grab some endpoints. As of now, yeah, I'll just copy this URL and paste it here. I'll rename this file to .env. And I'll just grab this API key and also paste it over here, since we are using Polygon zkVM API of Alchemy. Yeah, I think we are good to go. Let's go ahead and see if we have some funds on, yeah, I think this should be enough. So let's go ahead and deploy our egg token contract. This is a simple contract, as you can see here. It's just an egg token contract with a mint functionality. So it's a simple contract. Let's just deploy it. Deploy. Yeah, and CJS. Yeah. What it will do is it will just deploy this contract on Sepolia network. So as you, oh no, I actually need to define the network first because we have a couple of networks in the hardhat config. We have Sepolia, we have Cardano as well as A-Star. So I think, okay, it will throw us some error, but yeah, we can run the command again. So essentially it will just deploy this contract to Sepolia network. Oh, strange. It deployed. I think it deployed on a local hardhat chain. So let's go ahead and deploy it on Sepolia network. Yeah. And then we will try to, yeah, here we are. So I'll just copy this contract address, which is of egg token contract. And in the Bridget file, I have a couple of things. I'll just try to explain it. Yeah, this is a token address that we need to bridge from source chain, that is Sepolia, to Polygon zkVM Cardano. So I just paste this token address here. This is a destination address. A destination address could be anything, any EVM address. And yeah, so basically, we have an array. So we need an ID to indicate what is the destination chain as well as what is the source chain. But in this case, in our case, it is not the chain ID, but it is a separate network ID that we have created. So for Sepolia, it's 0. For A-Star zkVM, sorry, for Polygon zkVM, it's 1. And for A-Star, it's 2. So yeah, just to indicate this network IDs. And yeah, so here is a source network array. I have just created an array to, to bridge asset on the source chain, as well as to claim asset on the destination chain. You need a provider for both of them to interact with the contract of bridge asset, so of the unified bridge. We need provider for both of them. So I have just defined it here. We are getting private key from ENV. We are getting unified bridge contract ending in 582. It's constant on every single chain. Let it be Sepolia or Polygon zkVM. It's constant on all these chains now. And yeah. So source network ID is basically 0. For our case, we just deployed the contract on Sepolia, so it's 0. And we'll be bridging this asset to the destination network with having ID 1, that is Polygon zkVM Cardano. So basically, yeah, this is destination network ID, destination network address, token contract address, token amount that we want to bridge. And yeah, I think that's it. Now, what we do is we just create a provider, we just create a wallet, essentially to sign the transaction, and then we create a bridge contract instance. That is unified bridge contract instance. We provide unified bridge contract address, unified bridge ABI, as well as the wallet to sign the unified bridge contract address. Transaction. And here we have ERC20 token contract instance. That is to be able to mint those tokens first. We'll just first mint those tokens to our address, and we will approve those tokens to this contract, and then we'll try to bridge these assets. So I just created this ERC20 token contract asset, instance. I'll just probably write here the token address. And yes, I think that should work. And again, I'll just remove this. And I'll write token address here as well. Yeah, I'll just remove this as well and write token amount, the amount of token that we want to mint. Same goes for here. Token amount. Here I just remove this and I'll replace it with unified bridge contract address. Yes. So essentially what we're doing here is we are first minting those tokens to our address. That is the oh, my bad. This should not be token address, but this should be our address. So I'll just copy my address and paste it here in the string format. Yeah. So first we're minting those tokens, the egg tokens, along with the token amount to this address, that is my address. And the token amount is basically, so it's 18 decimal token. So since we need to mint one token, let's put 18 zeros here first. I'm not sure how many it was. Yeah, now we have 18 decimals here. And I think we are good to go. Yes, token approved, bridge contract, and yes. So let's first try to, so this running the script will essentially mint those tokens to this address and with the token amount as 1. And it will also approve the unified bridge contract to spend those tokens on our behalf. So yeah, let's go ahead and try to see if this works. I think it did. I think so. Let me just. I forgot to wait for this transaction to actually go through because minting and approving takes some time. So I will just wait for this transaction. Await mint dot. I'll just wait for one block as of now. And await approve transaction dot wait. Let's wait for 2 blocks to be sure that the transaction actually went through and is actually included in the block. And yeah, that's pretty much it. I'll go over through this code later on once we actually bridge this transaction. Once we actually mint this token to our address. Let's see if it goes through. Yeah, it will just console log out the whole object of the transaction, and we will just pick out this transaction and see on the Sepolia chain that it actually went through. Yeah, by the time destination network IDs again. So here, this bridge contract instance contains a bridge asset function which actually carries out the bridge transaction, and there are 6 things that you need to pass in. That is destination network ID, destination address, token amount, token address, and force update global exit route. So what this force update global exit route does is, if you put it as true, it will immediately update the global exit route on the L1. So otherwise, it will do it periodically. So if you want to force update it, you can do that too, but it will actually take some more gas fees, but not that much. But yeah, so it will update the force global exit route on the L1 so that you don't have to wait for this for periodically. So there is a bridge service API which is periodically updating this force global exit route on the L1, and the L2 is reading this data and actually sees if the if the transaction is ready to be claimed. So yeah, you can do that by just putting the flag as true. Yeah, as you can see, yeah, tokens just bridge transaction just went through. I just copy this address and see on portal.polygon.technology. I'll just connect my wallet and yeah, I'll switch to the testnet to Sepolia. And when I go to transactions, yeah, here we are. So yeah, transaction was bridged from Sepolia to Cardona. It takes 30 minutes to land into Cardona testnet. So yeah, and you can see, we just bridged for 1 ETH token, and yeah, yeah, it's done. And for Cardona zkVM, you don't need to claim the assets because we are running an auto claiming service in the you can say as backend. But let's say if you are doing otherwise, like if you are bridging asset from Cardona to Sepolia, you need to run this claim asset function by yourself. It's also in the code itself. So what it does is a high level overview is it just fetches all the Merkle proofs that we just talked about in the first part. It fetches the Merkle proof and verifies if these assets are ready to be claimed, and then it claims the asset once we call the claim asset function on the destination contract. That is, again, the bridge contract on the destination chain. Yeah, that's it. Thank you so much.